Okay, in this screencast, I'm going to talk to you about how to write an argument statement in APES. So pretty much every day in class this year, I'm going to be asking you to respond to an argument prompt. Every unit test you take from me will have a section that you'll be assessed on how well you can respond to argument prompts. And on the AP test in May, you'll have to respond to argument prompts. So we should go ahead and practice this a lot and get good at it. The good news is it's not that hard. Most of you are pretty good at it already as long as you don't let yourself get lazy. And it's something most of you have practiced in science classes before today. So let's just go ahead and review it and make sure that you're solid with this. Okay. So usually what's going to happen is in an argument prompt, we're going to ask you a question and present you with data. All right. And so you got to look at the data and use that to answer the question. So let's give an example here. Over the course of a year, the water temperature in a stream usually varies between 10 and 35 degrees Celsius. Would you expect fish species A or fish species B to be more abundant in the stream? So I need to, in this case, I have to extract information from a graph. The graphs are a pretty common way of presenting evidence in APES, although sometimes you're given data tables or other ways of presenting data. But in this case, it's a graph, which is probably the most common. So I know that the temperature varies between 10 and 35, so I have to use this information to extract information from this graph. So I'm going to go to 10 degrees. That looks like a DO of about 11. And at 35 degrees, it looks like the DO level is around 7.5. All right. So now I turn over here and I look at fish species A, and I see its relative population is very low at 4 milligrams per liter. It reaches its maximum at about maybe 8.5 or 9, and then it drops back down when it gets to 12. Although I don't know how realistic that is, but that's what we've got in our data here. And I look at fish B, and I see its population goes to 0 at 10. It has to be more than that to have any at all, and it reaches its maximum around maybe 13.5. Okay, so looking at this, I can tell fish species A is the answer, right? It's the one that can survive between 7 and 11, right? 7 and 11, man, that fish species is doing okay. But this other one is not doing so great. They barely make it at 11. Okay, so now I know what my answer is. But here's what you don't do: you don't say fish A. It's going to be fish A. Fish A does better. That's not an argument, right? That you're identifying which fish species survives. But if the prompt says, to answer or to make an argument about this, that wouldn't count. All right. So what you want to do is something you've heard of before. I'm sure you've heard of this. It's called the CER format for making an argument statement, and that is you're going to make a claim. You're going to present evidence that supports that claim, and then you're going to provide the reasoning, the scientific understanding that you have that links the evidence to the claim. You're going to do that every time. If you do that every time, you will be fine. If you don't do this every time, you may be fine, but you may not be. So let's just make sure the answer is you're going to be good. So start with a claim statement. In this case, I would say, I would expect fish species A to be more abundant in the stream than fish species B. That's a very clearly stated claim. I flat out told you what I think the answer is. Here's what you do not want to do. Do not start with the evidence. Don't say, since the temperature of the stream is, no. That is not a claim. That's evidence. That comes afterwards. Make a claim first. Don't start by disproving whatever counterclaim somebody might make. Well, the dissolved oxygen levels are going to be too low for fish. Don't do that. That you are asked a question: which species do you think is going to be more abundant? Answer that. You say, I think it will be A. Okay. Now, next you want to present your evidence, and here's where the finesse comes in. Here's if there's anything that can be a little bit tricky, it's this part here, but is really essential if you're going to get full credit. So I want to explain what evidence there is. I can't just write down the DO levels. I have to explain. I'm making an argument. So I'd say, since the temperature of the stream varies between 10 and 35, the dissolved oxygen level is going to vary between 11 and 7 milligrams per liter. I could say, as seen in the dissolved oxygen curve in the graphs below. Fish species A can live in water with DO levels between 4 and 12 milligrams per liter, while fish B only survives in water with DO levels between 10 and 16. So I've presented you with the evidence. There it is. That is the evidence on which I based my claim statement. So I got my C, I got my E, now let's go with the R. Now, sometimes the R statement, the reasoning part, is just going to be your way of showing I understand APES concepts and I'm working them in here. Right? In this case, yeah, we're going to take it from the evidence that we have here. So you're going to say, well, since the DO levels in the stream are usually below what's needed to support fish species B, but generally at or above levels at which species A thrives, it would be expected that species A would be much more abundant in the stream of fish species B. And then you just put that all together, and that's what it looks like when you put it all together. This, my friends, is what I expect from you when I ask you to make an argument. You want to make a claim. Here's my claim. You want to provide the evidence that allowed you to do it, and then show me why that evidence supports your claim. That's the reasoning part of it. Hey, thanks for watching. You're going to get good at this. I just know it. We'll get started day one.